Welcome back. Let's look at a rigid body problem and finding support reactions. This problem looks a little bit complicated. There's a lot going on, but I'll show you how you can break it down in simple steps and kind of digestible and solve it. A load of lumber that weighs 25 kilonewtons, this one right here, is being raised by a mobile crane. The weight of the boom ABC and the combined weight of the truck and driver are as shown. This is the weight for the boom ABC. This is the weight of the truck and the driver combined. Determine the reaction at each of the two front wheels H and rear wheels K. R. So this is a rigid body problem. We cannot ignore the size. The forces are all over the place. The line of action do not go through a single point. So first step is to draw a free body diagram for the problem, which we have to identify what do we want to draw a free body diagram. And then step 2, this is a 2D problem. We have to write equations of equilibrium. Summation of forces in x direction should be 0. Summation of forces in y should be 0. And then my third equation would be summation of moment about any point you want. About h, about k, about c, b, f, a. Even a point that is not on this diagram does not matter. So these are my main 3 equations. Based on what I'm seeing, we only have 2 reaction points at h and k, so we should have 2 unknowns, so we should be all right to solve with these equations. All right, let's start with step 1 and drawing free body diagram. Since we need reactions at these 2 points, I think I'm going to draw the free body diagram of this entire mobile crane. You do not have to include details when you are drawing a free body diagram. Free body diagram of this entire crane. So the first step is to isolate and redraw the outline of this, whatever you're drawing free body diagram of. So all you have to do is kind of do an outline of what is happening here. Very simple. So this is my outline. And step 1 is done. I don't care what's going on inside the boom ABC, all those cables, all the pins, the steering wheel, seat, driver, none of that matters. I'm just drawing the outline of the crane and I'm isolating the crane, meaning removing everything extra that I don't need from it. Step 2 is to draw active forces and moments. Active forces and moments are the existing forces, the existing moments that are trying to disrupt the equilibrium, trying to mess up the equilibrium. When I look at this problem, you know, I usually like to start from left to right or right to left so I don't miss anything. So starting from that side, I see at point A, I have a weight that is coming down and it tells me that it's 25 kilonewtons. So make sure you label your forces. If they're known, put the values right there with the unit. If they're not known, just use the variable, unknown variable for that force. But do not leave your forces unlabeled because they leads to later confusions. Kind of moving on, I see another force of 3 kilonewtons pushing down. Put it right here. Remember, force is a sliding vector. So this W, you can draw it down here. You can draw it up here. You can put it on top of point A. You can put it below point A. Does not matter because you're moving it up and down on the same line of action. Next, kind of moving on, the next active force that I see is this 50 kilonewtons kind of pointing, not kind of, it is pushing down. It's a weight. Weight is always going down. So these are the 3 main active forces that I see. I don't see any other moments, any other forces, anything else. Then I move on to my last step of free body diagram, drawing all the reactive forces and moments. These are the forces and moments created by supports, created by constraints, as a result of those active forces be on the body. There are 2 points of contacts here. These are known as a smooth surface, same as a roller. So they are same as a rocker, just a wheel as you see, or they're same as if you have just a leg, for example, a chair just sitting on the floor. So in all of these cases, which is also the case here, when I look at x direction, y direction, and rotation or moment, I see that they can freely move back and forth in x direction. So yes, they can move in x direction. They cannot, however, move freely in y direction. I know they can go up a little bit, but they cannot go any further down. So their movement or their motion is restricted in y direction, and that's very important for us. And then can they rotate freely? Yes, they can. They can all rotate. There's nothing that prevents their rotation. So yes, they can rotate. And we only look at this one that is restricted. So in direction y, their movement is restricted, and as a result, I do not have the ability to change the color. That's all right. As a result, we're going to have a reaction force in this direction that their movement is restricted. So at point H, I'm going to put a normal force pushing up. This is from the ground applied to that wheel, and I just like to call them normal force H. And then at this end point, also I like to put it normal force K. The problem says for each of the 2 front wheel, so this is for 2 wheels that I put on this free body diagram. It is good practice to add, look at your figure. I know the figure is now messy a little bit. So add the distances that you see between the forces. This one right here is 0.9 meters. The next one I have is these 2. That one is 2 meters, and the other one is 0.5 meters. And this is all we need, and this is our free body diagram. If you would like to pause the video at this point, grab a blank sheet of paper and try to redraw the free body diagram on your own and compare it. Now would be a good time. But I kind of redraw it. I put it, cleaned it up a little bit and put it here. That's the step 1. Free body diagram is done. Step 2 is use of equations of equilibrium. And I said we have 3 of them. Summation of forces in x, summation of forces in y, and moment. There is no force in x direction, so this one equation really doesn't help us. Summation of forces in y, I have 2 unknowns here. So as a result, that equation doesn't help me either. I can certainly write it. I can have summation of forces in y. Anything that points up is going to be positive. So let's just start from this side, make our way across this free body diagram. I see a 25 kilonewtons pointing down, that's negative. Another 3 kilonewtons pointing down, that's negative. I see an N sub H, that's pointing up, so that's positive. I see a 50 kilonewtons, negative, and I see another positive N sub K equals 0. 2 unknowns, 1 equation, I cannot solve it. So let's do another equation. X, I said, doesn't help me. Let's use summation of moment being 0. We have to decide which point you want to take moment about. Doesn't matter, you can pick any point you want, A, B, C, outside the free body diagram, on the free body diagram, H, K, any of those. I picked point K. Take moment about point K. So I'm going to take moment of all of these forces about point K. I start again from this side, making my way through the diagram. 25 kilonewtons, and that's multiplied by 2 plus 0.9 plus 2 plus 0.5. That is 5.4 meters. The rotation that is causing is this way. It is with my sign, so that's going to be positive. Next, I move on to the 3 kilonewtons. The arm for that is 0.9 plus 2 plus 0.5. And that equates to 3.4. Same way it's going, so that's positive. Then the next force I have is N of H multiplied by 2 plus 0.5, 2.5 meters. That one is trying to create a rotation this way, which is negative. Next, I move on to the 50. And that one, the arm for that is 0.5 meters. It's trying to rotate this way. It is with my sign, so that is a plus. Next, I have my N of K. The arm for that is 0. Plus or minus doesn't matter. That equals 0. You can ignore this and not write it at all because it passes through point K. The arm for that or the distance is 0, so that is totally acceptable. I have how many unknowns? Only one unknown. So this was a good idea to do this. If you do the math, which I did before recording this video, NH would be 68.1 kilonewtons. Remember, this was for 2 wheels. It says find each of the 2 wheels. So for each wheel, this answer is going to be 3405 kilonewtons. Maybe we could have marked it as 2NH and then just find NH. However you want to address that, just remember what I put on the diagram was for 2 forces or for 2 wheels. This is for each wheel. So now if I put NH of 68.1 in this equation, I should be able to find my NK, again, for 2 wheels. And that is going to be 9.92 kilonewtons. For each wheel, it will be 4.96 kilonewtons. As a practice, to take this to next level, let's assume we didn't know NK. Take a moment about point H. Again, as practice, write the equation for moment about point H and see if you can find NK based on using that equation, and see if you get the same answer of 4.96. Thank you very much.